In this video, we're going to get back to the C# programming language itself, and we're going to talk about declaring and using variables. So on screen, you've probably seen a math problem like this before, right? Basic algebra. 5 plus x equals 7. Even if you didn't know algebra, I'd ask you, what's the value of x? You would obviously say 2. So using that same logic, take a look at this. X equals 7, y equals x plus 3, console.writeLine y. What do you think it's going to be printed to the screen? Well, I think based on what I know already, 10 is going to be printed to the screen. And that's exactly right. You just read C# on your own without a whole lot of help on my part. It's just common sense, right? And that's the point I wanted to get out. There's a little bit more to it than that, obviously. There always is. But the name for x and y in C# is called a variable, meaning that it's a bucket in your computer's memory to hold a value. In this case, these buckets are holding numeric values. But we can create buckets just the right size for dates and times, for strings of text, for really big numbers, or numbers that have numbers after the decimal point. In the cases that we just talked about in x and y, we expect these to be numeric values. We know that, but we have to use C# to express this to the .NET Framework runtime. Remember, the runtime is what actually allocates memory for our data. So here we have two data items, and we have to tell the runtime to allocate some space in memory sufficient to hold that data. So we would declare our variables. And to do that, we're going to need to declare our buckets before we start using them. So what I'm going to do here, I'm going to go ahead and blow this away. I'm just going to select it and hit delete on my keyboard. It's gone. So I'm going to declare my two variables now, int x, int y. It's as easy as that. Int is the C# term for integer, a mathematical term referring to a number that has no fractions or decimal values. Again, our goal in declaring variables is to tell the .NET Framework runtime to save a place in memory for our numeric values. And then after that, we can access our variables, assigning variables or values to our variables, or reading the values out of the variable. And we did that in the following lines of code. Well, actually, let's write that code here. Let's do this. X equals 7, y equals x plus 3, console.writeLine y. So that equal sign is an assignment operator. In English, that line is basically saying that we set the integer called x to the value of 7. Then notice that we're sending the value y into the method WriteLine that we used in the previous videos, trusting that it'll know what to do with that, with the integer that we passed in. So is this going to work? Well, let's go ahead and run it. Well, actually, let's do one more thing here, because we've already learned our lesson before about not being able to see what we're actually working on. So I added a console.readLine. Let's run the application, and we can see the number 10 printed to the screen. So it absolutely worked. So let's do this. Let's go down a little bit further here. Well, actually, let's just go right here. Make some space for ourselves. And what if I wanted to create a variable that held a string? I could do it like this. String my first name. My first name. Oh, there's IntelliSense. Look, it knew that I created a new variable called my first name. So now all I got to do is just hit the equal sign, and it typed the rest of it out for me. Pretty cool, huh? So let's get back to the matter at hand. I'm going to type a literal string Bob and then hit the semicolon at the end. And notice when I hit enter, it added some formatting. It added some spaces here for me. I didn't have to type the space bar. Again, the IDE is awesome. It will format your code for you so that it meets standards that other developers would find acceptable. Last line of code I'm going to write for now is WriteLine, my first name. And now let's see what happens. Let's run the application again. So we get the number 10 from the first example, and then Bob from the second example. Okay, so notice that the string is, that word string is the key word for creating a bucket in memory that can hold textual information. Also notice that my variables can be named anything I want. within certain prescribed limits, right? As a convention, most programmers do what I did right here. Use a lowercase m in the case of my, and then followed by a capital letter at the beginning of each additional word. So I put a capital F for first name and a capital N for the word name. And this is called camel case, and you'll hear people talking about it over and over again. It's just a way of it's a convention that allows you to more easily read what's being written. So whenever I'm creating a local variable within a method, I'm going to use camel case, and you should get in the practice of doing this as well. So for the rest of the videos today, and probably throughout the rest of this week, we're just going to stick with using strings and integers, numbers and letters. What else could we possibly need? We'll get to dates and all that stuff later. There are probably a dozen others that you'll eventually want to know, and eventually we will cover these in subsequent videos. One thing I do want to point out, let's do this. I'm going to create one variable called x and another variable called x. Now, what do you think about that? What if we did, for example, x equals x plus 2. All right, it's not complaining. Let's see if it runs. And it does. And you're saying, well, how can you have two variables, two buckets in memory with the same name? Aha, they don't have the same name. C# is a case-sensitive language, which when you get started will bite you so many times. As you get used to it, you'll be a little bit more sensitive to it, and that's why naming conventions are so important, to be consistent in how you name things. But a lowercase x and an uppercase X are two different buckets in memory. If I were to try and do two lowercases, notice that I get a little red squiggly line. If I hover over it, you can see it wants to give you an option to rename it. And notice it says, well, you can rename this to a capital X if you want to. Or if you just want to look at the error message, it says the local variable is already named X. It's already defined in this scope. You're like, right, I know, that's kind of dumb of me. So let's just go ahead and get rid of this. Select that, and then we're going to get rid of this. So just make sure that you understand that capitalization is important. The same is true with my string here. I'm going to copy it and change my first name to my first name, and those are two different variables in memory. Okay. Oh, one other thing. We can condense these two lines of code into one line of code like this. Here, what I'm going to do is just delete all of that. And so now we have the declaration and the assignment of the variable, whoops, all in one fell swoop, all in one line of code. Experienced developers like to write less code, so they're always looking for a convenient way to reduce the number of keystrokes that they have to type. This is one reason why you would do this. Another reason you would want to do this is because you don't want your values to never be, your variables to never be assigned a value. So to initialize them with a beginning value is a good practice. Okay, so before we finish out this video, I'm going to leave you with a little head scratcher. And I don't even think I'm going to answer this little quiz I'm about to give you until tomorrow. So I'm going to let you really think about this for a moment. Let's write some more code. Here, in fact, let's clean up some things here. Let's get rid of some spaces because I'm kind of sensitive to those sorts of things. Actually, let's go ahead and just blow away all this. Hopefully you typed it in yourself and it served its purpose and we can move on from there. So let's do this. Int x equals 7. Pause the video if you need to catch up with my typing, okay? So int x equals 7. We're going to change int y to a string y, and we're going to set that equal to Bob. Then we're going to create another variable called my first try equals x plus y. All right, now let's run the application here. Actually, let's do this console.writeLine. Let's see what we actually did here. My first try. Okay, pause the video if you need to catch up. I'm going to run it, and let's see what happens. It prints out 7 Bob. Is that right? Yes, because 7 plus Bob equals 7 Bob. Okay, makes sense. So now let's try something a little bit different here. Let's go int my second try equals x plus y. And then I'm going to do this. Whoop. I was going to change this to print out my second try, but before I can even do that, I already see that there's an error here. Cannot implicitly convert type string to int. So there's a red squiggly line under the second x plus y. Do you care to take any guesses as to why that might be? Well, I'm going to keep you guessing until tomorrow. Hey, I got to keep you coming back somehow, right? So tomorrow I'll explain why that is and how we can remedy that situation. So okay, great work so far today. Let's continue moving on. You're doing great. We'll see you in the next video. Thank you.